Hello children! Have you ever thought about why space looks so black although it is filled with stars? And how can we see everything around us? But you already know the answer. Light lights up everything. In this lesson, we will find answers to many such everyday phenomena around us by learning about light and the reflection of light. I am Shubhajit, and today with me is Persis. We will explain about properties of light and the reflection of light on a plane mirror in this session. From the chapter on light reflection and refraction. In this lesson, you will be able to understand the reflection of light, learning outcome, nature of light, light reflection, laws of reflection, plane mirror, image formation in plane mirror. Keywords: light reflection, plane mirror, image formation. Before going into the subject, let us look at this mind map. Let's start. Light is a form of energy essential to see everything around us. Light is an electromagnetic wave which is fundamental to the universe. Light travels without any medium. Space is empty and still. We can see the stars far away. The speed of light is 3 into 10 to the power 8 meter per second. Sunlight takes 8 minutes and 20 seconds to reach the earth. Nothing moves faster than light in the universe. Modern physics tells us light has a dual property: wave and particle duality. We are going to treat light as a wave. In the case of the particle, nature of light, it is made of photons. Photons are tiny packets of energy. We can assume light propagates in a straight line. We call it ray. Light interacts with every object in its path. There are 4 kinds of interaction that happens: reflection, refraction, scattering, and absorption. Some objects emit light, like electric bulbs and candles and the sun. Stars and such objects are called luminous objects. Most of the objects around us reflect light. which is how we see it. Books, trees, human beings, other planets, and moon do not emit light, just reflect the light from other luminous objects. Now, let's learn together the terminology of the reflection of light. The process of bouncing back light rays from any surface is called the reflection of light. We call the light ray an incident ray that falls on the surface. The incident ray gives the direction of light falling on the surface. The particular point at which the incident ray falls on the surface is the point of incidence. The light ray coming back from the surface is called a reflected ray. The perpendicular line to the surface at the point of incidence is called the normal. The angle made by the incident ray at the point of incidence with the normal is the angle of incidence. The angle made by the reflected ray at the point of incidence with the normal is the angle of reflection. Next, let's look at the laws of reflection. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. The angle of incidence is equal to the angle of reflection following the image. Angle I equals to angle R. For example, if the angle of incidence AON is 30 degree, then the angle of reflection NOB will also be 30 degree. Always. The laws of reflection are true for every surface: plane, curved, smooth, and rough. If every object reflects light, what is so special about mirrors? Why can we see our clear reflection in mirrors only? To find that answer, we have to know about the types of reflection. You see, different surfaces reflect light differently. There are two types of reflection depending on the surface. Regular reflection. In the case of very smooth surface, the reflected ray come back in the same direction. If a parallel beam of light falls on a very smooth surface, then the reflected rays will also be parallel. Diffused reflection. In the case of rough surface, the reflected light rays come back in all different directions. That is why we call it diffused reflection. The angle of incidence for parallel light rays is separate because of a roughness of the surface. To obey the law of reflection, the angle of reflection is also different. So, the reflected light comes back in different directions. We can see every object around us for diffused reflection. Finally, it is time to learn about mirrors. Mirrors are the perfect reflectors. All the objects reflect some of the light, but mirrors reflect most of the light. The best reflection capacity of a mirror is about 95%. For everyday applications, a mirror with a reflectivity of 90% is enough. Mirrors are made by depositing metals on glass because metals have very high reflectivity. Silver has the highest reflectivity. So mostly silver is used. Aluminium is also sometimes used. A thin coat of silver is deposited on a side of the glass so that light gets reflected. To avoid any transmission of light, the silver is painted with opaque paint. When light falls on the mirror, it goes through the glass and the metal on the back of the glass. Silver or aluminium absorbs the light immediately, releasing the same light. This light comes back as the reflected light. Let's understand image formation in a plane mirror using ray diagrams. First, we are going to start with a point. Then we will use a line. Every object that we see in mirrors can be understood using the same principles. The incident light from the object falls on the mirror. Incident ray OA, then it gets reflected following laws of reflection AX ray. Let's take another ray OB. It makes the incident angle I1 and gets reflected angle R2. Because of reflection, the reflected ray AX and BY diverging. But if we extend them on the back side of the mirror, just to show you, then the rays meet at the point I, like rays coming out of the object I. And that's how the reflected image is formed in the mirror. Next step, an object where AB is the object. We are going to consider 4 rays. Please note that the height of the object and distance from the mirror is the same for reflected image. Let us first understand the total reflection rays, namely AP and BO. The angle of incidence is 0. And so is the angle of reflection. For AO, OC is the reflected ray. Similarly, QE is the reflected ray for BQ. If we extend them, they converge on A dash and B dash. Connecting the ray lines, we get the reflected object. The image created by a mirror is virtual because we cannot see it on a screen. You can easily see this from the ray diagrams. The phenomenon of the left appearing as the right and the right appearing left in a mirror is known as lateral inversion. The ambulance is written as the reflected image so that it is shown properly in the rear view mirror of the cars.